Hello everyone and welcome. Hello, this is Aurora with the Central Coast Astronomical Society. Welcome to tonight's presentation. We are going to be doing a tour of the night sky, and this is for September. We're going to be going through all the cool things you'll be able to see with either a pair of binoculars or with your naked eyes, just by going outside, looking up, and you'll totally understand what you're looking at after tonight's session. Okay, so Kent, I've got a picture of you at a stargazing party here. You're sitting down looking at some star charts. I've got a picture that I'm showing everyone here. Do you want to give us a little 60-second intro to your equipment and how and your background?
Okay, yeah. Usually at the star parties, I haul my 20-inch. It's a 20-inch star splitter. Has no drive. You just push it around. It's a Dobsonian. Has a big mirror, so it's a reflector. And the star chart I'm probably looking at is Sky Atlas 2000. It's like, the best starting point. Usually I'm looking through, I'm looking through the finder scope. I have an 8x50 straight through finder scope on the 20-inch. So usually we're looking out there for something bright initially because it's still light out. So right now you'd be looking for Jupiter or Saturn. And so basically you line up your finder scope with your eyepiece and get those two in sync. So when you look through your finder scope and it's in the center of your finder scope, you also look through the eyepiece, make sure that the object is in the center of your eyepiece.
Awesome. And you didn't always used to have a telescope this big, right? You had an orange one.
Oh, that's my C8. Yeah. Yeah, I used to use that until I got the 20-inch. And so I don't use the C8 that much any longer. But the 20-inch is a pain in terms of being a big scope to tear down and put together. And so the views are pretty awesome.
Awesome. Wonderful. Okay, great. Well, we're going to go ahead and get started with our tour of the night sky. I'm going to go ahead and bring up a planetarium software that I'm going to be using for tonight.
Pardon?
Do you want to start with Cepheus?
Yeah, let's start with what they call the Great Square, which is made up of one of the stars is the bright, Alpha Andromeda. The other three are in Pegasus, and it forms a big square in the sky, and so that's why they call it the Great Square. And it's just kind of a cool asterism. And actually, when it rises, it looks more like the Great Diamond rising up. But eventually, when it gets up there, things twist as they get up into the sky. It looks like a square when it gets up a ways, but initially, when it comes up, it looks kind of like a diamond.
Nice. Okay, let's before you really dive into this, let me show people how to find the Great Square, because they can see a square, but honestly, when they go out tonight, this is what it's going to look like. So it's going to look like a whole bunch of dots. So how do you find that Great Square? So here, I'll connect the dots for you now. Okay, so for the northern hemisphere, if you look east, and it's not very far above the eastern horizon, if you'll look east, and you're going to see four stars that really stand out as being, it'll look like a diamond, kind of a square on its side at a 45. That's going to be the Great Square. A lot of people can recognize, we're going to talk about that one later. A lot of people can, if you go look to the south, we talked about Sagittarius last time. You can see the Milky Way, okay? So it's about that high, but now you're looking east, and we're going to see the Great Square here. Okay, Kent, go ahead.
Okay, got the Great Square then.
Yep.
We'll talk about the constellations that make it up later. The next asterism for tonight is the W in Cassiopeia. And that's a really nice constellation with a lot of neat objects in it.
Yes.
And remember how we talked about how you find Cassiopeia or the W?
Yes, I do. Let me back up a little bit so we can show people how to find it. Okay, wait. Before you say anything, Kent, hang on a second. Okay, so here we go. Let me shake up the night sky. Ready? Shake, shake, shake. Okay. So most people can find the Big Dipper. And it's for the northern hemisphere, it's up most of the time. So here we are. We're going in my backyard. And now you tell me, where's the Big Dipper? Do you see it anywhere? Here, if I zoom in a little bit, does that make it easier? I know on a computer screen it can be a little tough. Okay, do you see it? Do you see the bowl? Now do you see the handle? Okay, so there's the Big Dipper. Now, if we're going to need the Little Dipper also. So we're going to take the Big Dipper and we're going to, here, I'll connect the dots here. You see how the Big Dipper is this here? Okay, so we're going to take these two here and we're going to connect them and extend. This is Polaris. This is the pole star. This is where the North Pole of the Earth is currently pointed to. This is the handle of the Little Dipper. Do you see that? So if I show the lines now, if we connect the dots, you can see this is part of Ursa Major. This is the Big Dipper. This is a star pattern that we can see. And if we connect these two, this will lead us to Polaris. And this is the handle of the Little Dipper. All right, Kent, go ahead and tell us, how do we find Cassiopeia?
Okay, go to the bowl of the Little Dipper, or the Big Dipper, and look at the star where the handle attaches. It's the fainter star that's in the bowl of the Big Dipper there. And if you draw a line from that star over to Polaris and continue it on straight, you'll run into the W of Cassiopeia.
Right there. So we took the handles of both, made a line between them, and then extended almost that far, and we have Cassiopeia. And if I label it and connect the dots, you can see it's right there. Isn't that cool? So you're just connecting the two handles.
Actually, no.
No? Oh no! What did I do wrong?
No, it actually works with the way you're doing it, but in the book they were talking about, see the faint star in the bowl, the faintest star in the bowl?
Yes.
Where the handle attaches to the bowl. They were saying draw a straight line from that star in the bowl to Polaris, and then continue it on to get to Cassiopeia.
Okay. Well, take your pick.
I like your ways better because people can see. Actually, Mizar and Alcor, the middle star in the handle of the Big Dipper, by the graphics you're showing, if you draw a line from that through Polaris, it'll hit right into the W also.
Exactly.
I guess the thing to remember is they're on opposite sides of the sky.
Yes.
So a lot of the times when the Big Dipper is down, Cassiopeia is up nice and high. Or if the Big Dipper is, in the west, Cassiopeia will be in the east.
Right. So here's what Kent is talking about. As this is, I sped it up so it's rotating, so we're passing time even faster. And you can see how Ursa Major is going to set, and then Cassiopeia is going to be very high in the sky. Okay, go ahead, Kent.
Okay, and let's see, we covered the asterisms. Now I think we should start on the, let me bring out the mythology, okay?
Yes, please.
Because we've got a list there, and the mythology, all these guys tie together. Cepheus, Cassiopeia, Perseus, Andromeda, and Pegasus all tie together in the old legends. And there's all sorts of variations, but it goes something roughly like this. Cepheus was the king of Ethiopia. Cassiopeia was the queen of Ethiopia, and Andromeda was their daughter. And unfortunately, Cassiopeia bragged about how beautiful her daughter was, and it kind of made the sea nymphs angry. So they went and complained to Triton, the god of the sea. And he sent out a monster, a sea monster, to ravage the coast of Ethiopia. And the god said essentially, if you chain your daughter to the rocks as a sacrifice to the sea monster, then they'll leave everyone alone. So that's why Andromeda is called the chained lady, is she's chained to the rocks as a sacrifice to the monster. And then Perseus is the hero. He's the guy that's a son of Zeus, and they often show him holding the head of Medusa. A Medusa was a lady with snakes in her hair. If you looked at her, you turned to stone. And so he killed Medusa and used the head like a weapon. He put a shroud over it. And he also had Pegasus. That was a winged horse, is another gift. He got a bunch of gifts from the gods. And so when the monster was attacking Cassiopeia, he flew over and essentially dropped the equivalent of a thermal nuke on the monster. He, pulled the shroud off of Medusa's head. The monster saw it, turned totally to stone, and died right there. And so that's the whole legend, my quick and rough cut of the legend. There's all sorts of variations on it. In fact, there was a movie made in the 80s called Clash of the Titans.
Yes, people are already referencing it in the chat box and saying that you have to go back and watch it now. So they already caught on to our theme this month.
One extra thing, the sea monster is also in the constellations, but it's so far south and so far east, it is not something to be seen this month, maybe next month. It's called Cepheus. They have it as a whale, but it's also the monster. And so that's the whole legend behind these guys.
Awesome. Okay, well, let's go back to the science side of things, shall we? You want to start with Mu?
Yeah, this is in Cepheus, who's the king. Okay. And unfortunately, he doesn't have a really bright constellation.
No.
It looks more like kind of like a jack-in-the-box. But anyhow, Mu, Cepheus is called Herschel's garnet star. When you look up there, you see there's a tint to it. But in reality, it's a monstrous size red supergiant star. It's so large that its surface is beyond the orbit of Jupiter. So we're talking about a monster star. It's just humongously large, one of the biggest stars you can see with the naked eye. It's about 100,000 times brighter than the sun, and for looking up there, it's probably the brightest for the magnitude range. It kind of varies. It goes between the fifth and the third magnitude, so it gets a little bit brighter, gets a little bit dimmer, but for most of the time it's around the fourth magnitude.
Okay.
But it's a really big star. It's about 2,000 light years away in distance.
Awesome. Now let me show folks how to find it before we go too much further. It's going to be almost straight over, well, not quite straight overhead. So if we're looking again at the sky, and again, let me connect the dots real quick and then show you. Remember, we started with the Big Dipper, we found the Little Dipper, and then you're going to continue on. So we have the Big Dipper, we're going to connect the bowl the way we did to find Polaris, and then we're just going to keep extending that line till we find a little triangle. Now, if we've gone over here to Cassiopeia, we've gone too far. So we're looking for this star pattern between the Little Dipper and Cassiopeia. So here, I'm going to turn off the stars. I'm not going to turn off the stars. That would be a totally different class. I'm going to turn off the lines. Okay, and I'm going to get rid of that, and I'm going to move the sky a little bit. Can you find the Big Dipper? Can you find it? Okay, good. Right here, you see it? Big Dipper. Now, where's the Little Dipper? Quick, quick, quick. Point it out with your fingers. Where is it? Where's Polaris? Which one? Is it this one? No, it's this one. Remember, we connected these two parts of the Big Dipper's bowl here. Okay, now, do you see Cassiopeia? If we connect the handle stars together, we go to Cassiopeia. That's too far. So we're going to connect these two on the bowl, go to Polaris, and then go a little bit further until we start to see faint stars in a jack-in-the-box pattern. Do you see it here? It's hard to see because those are kind of faint stars. Do you see it now? I'm going to turn it off. Do you see it? I'll turn it back on. I'll turn it off. Now, where's the star we were just talking about? It's going to be a little orange star right here. So I'm going to turn it off again, see if you can do it. Find the Big Dipper. Okay, find Polaris. Okay, and now what are you going to do? Okay, you're going to go a little bit further. Okay, here are the 4 stars in the box. Here's the triangle. And the garnet star is right there. You did it. Awesome. Okay, Kent, go ahead. There's something else here too, isn't there?
Yeah, actually, there's a lot of dust between us and Mu Cephei or Herschel's garnet star. There's so much dust that it blocks about 2.5 magnitudes. So if there wasn't any dust, it'd really be really stand out there. Might be the brightest star in in Cepheus. But there, the dust and 2,000 light years, you can gather up a lot of dust. Does dim it down a bit.
It does. Now, there's something closer to the handle of Polaris, right? Or the Little Dipper, I mean.
Oh, the next object?
Yes.
Okay, next object is a really, really old open cluster, which is called NGC, which stands for New General Catalog number 188.
Mm-hmm.
And it was discovered by John Herschel on November 3rd, 1831. It's just a little faint cluster. The significance of it is how old it is. It's on the order of 5 billion years old, and it's still holding together. The cluster our sun was formed in broke apart a long, long time ago.
Mm-hmm.
But for some reason, this little cluster of stars has hung together for 5 billion years. So that's, for an open cluster, that's ancient. That's really a long, long time for that cluster. So that's why I thought it was an object worth discussing, just because it was so ancient.
Right. And just so you see it here on the, whoops, I unclicked it, sorry. Okay, so do you see the Little Dipper here? If I turn on the lines, do you see it? How close it is to the handle? So with your binoculars, when you're looking at Polaris, you just want to start your journey towards Cepheus, and then it'll be right by the handle. Okay, good.
It's only about 4 degrees from Polaris.
Yeah, it's really close by. Okay, great. Do you want to continue on to Cassiopeia?
Yeah, let's go on to Cassiopeia and discuss one of my favorite clusters, or open clusters, and that's the Owl cluster, or NGC 457.
All right. That's one of my favorites, actually. It really does look like an owl.
Yeah, in my 20-inch and my big 2-inch eyepiece, it looks like a stick figure. You got the 2 bright eyes, you got little body, you got the feet, and the wings are going up on either side.
Mm-hmm.
So for kids, it's really easy when you tell them it's a stick figure. They usually catch it. Adults take a little bit longer,
It totally is. Now, this owl is actually kind of upside down. So the 2 eyeballs here, and here are the wings, and here are the little feet. So, yeah.
Since my telescope reverses everything, he flies upright in my scope.
Okay, so you know how to find Cassiopeia. We already talked about that. So make yourself a little note. There are 2 triangles in Cassiopeia. This is by the shallower triangle here. And you can kind of see it right there. And is this a binocular object, Kent?
Oh yeah. It's not very bright, but it's a binocular object. If you have big binoculars like yours, it should show up fairly well.
Mm-hmm.
What I usually do is use those last 2 stars in the W there, the lower 2 stars, draw a straight line out from them, and it kind of comes close to the owl cluster.
Nice. And you can find the little owl, which is very good because it's close to Halloween, so people can look at the owl up in the sky. See? Doesn't he look like an owl? Okay, great. Do you want to talk about Eta?
Yeah, let's talk about Eta.
Okay.
It's, a naked eye star. It's, between 2 of the brighter stars in the W, and it's a visual binary, which is kind of interesting. You can't really see it as a binary, but when you look at it, you can see the star that makes up the binary. And it's built out of 2 stars. One is yellow, the other one's kind of orangish. They're about 13 arc seconds apart. So they've got a nice separation to them. The other thing is the brighter yellow one's about 3.5 for magnitude, 3.5 for brightness. And then the fainter reddish one is a 7.4 magnitude star. And the interesting thing is the yellow one is very close to our sun's brightness. So the pair of them is about 19 light years away. So if you wanted to see what our sun looks like at 19 light years, you just look up there at Eta Cassiopeia, and you'll see that's how dim our sun would be if it was 19 light years away.
Nice.
Also, it takes about 480 years for them to go through a cycle, for one to orbit the other.
Yes. Yeah, that's
And
just
it was
amazing.
found by William Herschel in 1799.
Perfect. And I was thinking was there any more in? Oh, yes.
There's
NGC.
another.
Yeah,
There's
go ahead.
actually a couple neat ones, but there's
Yes.
the next in line is a really beautiful open cluster. It was discovered by Carolyn Herschel using a little sweeper telescope. She found it on October 30th, 1783. It's magnitude 6.6, so some sharp-eyed people could probably see it naked eye if you had good conditions. It's really a rich open cluster. They also call it Carolyn's Rose because there's loops and there's a lot of detail to that star cluster, and it's actually between Sigma and Rho, Cassiopeia. So those two stars bracket it, and makes it easy to find in binoculars. Definitely, binocular object. It's really pretty in a telescope.
Yeah.
No matter what size you use. And so, NGC 7789. It's kind of a hard number to remember. There's so many NGC numbers, but also it's called Carolyn's Rose.
Nice.
So that may be easier to remember it by. But it is a beautiful object there in Cassiopeia.
Perfect. And how about M52? And then you can tell us what the M is for in a minute.
Yeah, that's a Messier. M stands for Messier. Charles Messier was a French comet hunter, and he made up this nuisance list of fuzzy objects, and he was dealing with really, really bad telescopes. I mean, really small telescopes, so everything looked like a blob. But he was looking for blobs that moved, which ended up being comets. He didn't really care anything for the blobs that didn't move, so he made up a nuisance list of the blobs that looked like comets but weren't. And that turns out to be the list that all the amateurs start with, that has all the really neat objects. It's really a nice beginning list.
It was the list of things not to look at because he wanted to be known for comets. And now it's what astronomers look at first.
It's the thing people don't remember as comets. They remember as nuisance list.
Yes.
And this was number 52 on his nuisance list. And, it's a beautiful, nice little cluster, fairly bright. Let's see if do I have a magnitude there? Yeah, I have magnitude 6.9. It's about 4,600 light years away. It's just a nice little cluster. You can see in binoculars. The previous cluster, Carolyn's Rose, it's 7,600 light years away. So it's getting out there. But M52 is in a little bit closer at 4,600 light years away.
Yeah.
And the really kind of interesting thing is you've got this open cluster, and then about 35 minutes, I think it's off to the east, or it may be the west. I can't remember for sure. But there's a nebula called the Bubble Nebula, and it's a super hot star in a nebula is blowing a actual bubble, and it's not centered in the bubble. It's actually off to one side, and in my 8-inch, I've actually seen some of the curvature of the bubble. You can't see the thing all the way around, but you can follow it a little ways. So the bubble's kind of like an extra that M52 is usually associated with in photographs and things like that. There, you've got it.
Yeah, so you can look at both of these, and they're really just between the Cepheus and Cassiopeia. So they're really easy to find. So just kind of let your eyes wander through the binoculars that you have, or just look up, and you'll be able to see those objects are pretty much in between both of the constellations.
Yeah, M52 will be the easiest. Trying to see anything of the bubble would be kind of rough with just binoculars. But because it's nearby, I figured I'd bring it up.
Awesome. Okay, should we move on to Perseus?
Yeah, let's move on to Perseus. And Perseus is usually shown as, a hero with his sword in one hand, and he has the head of Medusa in the other. And our first star is called the demon star, Algol, or the Eye of Medusa. And there's some debate about whether the ancients knew that it got brighter and dimmer or not. There's no written records, but they really put the evilness onto that star. And so there was something they didn't like about it. But they made it the evil Eye of Medusa. And that's shown in like the decorative type pictures of constellations where they would overlay a neat picture. Mm-hmm. It's always shown as the head of Medusa there. And it's kind of interesting because it does get brighter and dimmer. And what it turned out to be is what they call an eclipsing binary star. The two stars are so close that you can't separate them with even big telescopes. You have to use spectral analysis to separate them. But what happens is the brighter star, which is kind of bluish, is 3 times the diameter of our sun and about 100 times brighter than our sun. They're located like 93 light years away. And then its companion, which is really close in, is just about the same size, about 3 times the diameter, maybe a little bit larger, but it's only 4 times brighter than our sun. So you've got one star that's 100 times brighter than our sun, and one star that's 4 times brighter than our sun, and they're separated by about the 20% the distance from Mercury to the sun. So they're really close together. And what happens is when the fainter star passes in front of the bright star, it really dims it down. And so about every 59 hours, the Algol star, Algol, it drops from 2.1 magnitude down to 3.4 over that 5-hour period. And then once it gets down to 3.4, then it starts getting brighter again. It takes another 5 hours for it to get up to 2.1. So it has a noticeable difference. People can track it with their naked eye if they're patient, and They use the surrounding stars as guideposts for how bright it is. But it goes way back for a variable star. It's the second known variable star. I think it was found in like 1667. So that's going back before, that's way back.
That's a long time ago.
Yeah, before Messier, before Herschel. It goes way back on that. But yeah, it's the second known variable star. The first known variable star is one they call Mira, and it's in Cepheus, the monster or the whale, and it is one that just the physics of it gets brighter and dimmer due to pressure variances on the inside, and so maybe we'll talk about that one another time.
Yeah, maybe in another one. Yes, definitely. And for those of you who are just popping on, I know people pop on and off. This is Aurora and Kent and Brian with the Central Coast Astronomical Society. We are doing stargazing for the month, and we're walking you through some of the constellations. So tonight, when you go outside, you look up, you know exactly what you're looking at in this part of the sky. So Kent is sharing his knowledge with you. He is not sitting in front of star charts. He's simply on the phone having a conversation, and I am providing the Planetarium Star Show visuals to go with it. And again, if you do have questions, you're welcome to send us an email, questions@centralcoastastronomy.org, or you can put it in the chat box. Brian is doing his very best to answer as many of those as possible. Okay, so Kent, let's see, we talked about Algol. Do you want to talk about the double cluster?
Yeah, let's talk about the double cluster
Okay.
because it's a naked eye object.
It is a naked eye object. That's awesome.
If it's dark and you can go out, you can see this little fuzzy patch kind of between. It looks like it's between Perseus and Cassiopeia, and it's been known, way back. It's one of the ones that they could see and go, well, we don't know what it is, but it's a fuzzy patch, and they think it goes as far back as the 2nd century BC to Hipparchus's star catalog.
Wow.
But there's no existing copies. The next star catalog that kind of referenced it was Ptolemy's in the 2nd century AD, where he talks about these fuzzy patches in the sky or little clouds in the sky. And I think he gave Hipparchus credit for that. But it's way old. It's one of those that's listed. There isn't really a discoverer because it's always been visible up there. And so the big question is, why didn't it have a Messier number? It does not have Messier numbers. And in fact, the double cluster, it's got NGC numbers. There's one is called NGC 869. The other one is NGC 884.
Yes.
And they're two beautiful open clusters. You can see it in binoculars, but in a telescope, it just really blows you away.
Yes.
It's really, especially when you use low power so you have a wide field. And the neat thing is there's some little orange stars in between. I think there's like 5 stars that you can actually see the orange tint that are around these guys. So that's always really cool.
Now, Kent, let me ask you a question that's been coming in a number of times here. People are wondering, can you really see the different colors in the stars?
Oh, yeah. Yeah, I mean, we're talking tints for the most part. It isn't like a knockout red. It'll be reddish tint. It's kind of like, pale colors like watercolors or something like that. It's mainly tints. You don't see a bright blue. You don't see bright, yellows. You usually see tints, but it's definitely recognizable. And, planetary nebulas, you can actually see green or blue. Shows up quite well, depending on whether you're, not colorblind for low light conditions. And so you can definitely see colors. In fact, when I got my 20-inch scope, the first thing when I hauled it out and wanted to see how it was working, I put it on the Orion Nebula, and I could see green around the trapezium with my 20-inch, and I was going like, whoa, this is good. I knew I got a good scope. I'd purchased a really decent scope at that time.
Yeah.
So, yeah, there's a lot of colors. There's some variable stars. There's one called R. Leporis that if you catch it at a minimum, it does look like a drop of blood on the sky. It is red, but you got to catch it at the minimum.
Yeah.
So you have to do some research on R. Leporis, but it's very red.
I was going to say, we should probably make the distinction that you'll see the tints, but the nebula will not appear in color. Like I've got a picture right now up on Stellarium.
It's rare to see any color in the nebula for the most part. The brighter planetary nebula are an exception, and there's one other exception, which is the Trifid. For some reason, I see a light pink on the Trifid with my 8-inch. That just may be me, but I think other people have mentioned it also. And so, yeah, most nebulas, they look white.
Yeah.
And that's about it, you know.
And your eyes are not as able to detect all of those frequencies the way a camera can, the way back in the day the film could, the way the CCD cameras can, even in like your cell phone. So your camera has a greater ability to see many more wavelengths than your eye can process in that moment. So,
the other thing is
I know the chat is exploding right now, asking for equipment recommendations. We'll answer those at the end, and yes, I will tell everybody about the giant binoculars behind me as well as the telescope. So I will answer all the equipment questions at the end. You're welcome to put your recommendations in, of course, but I want to save that for the end of the show. Okay, so Kent, where were we? We were doing
We were doing the double cluster.
The double cluster. Okay, we did that.
And,
Do we finish with that one? Are we ready for M34?
Yeah, let's finish with it. We're
Okay.
starting to get low on time, so
Yeah.
let's go for
keep going.
M34, another Messier object, an open cluster.
Okay.
It's mag 5.2, so that's fairly bright.
Yes.
And it's in Perseus there. It's, you know, I guess if you've got really good eyes, 5.2, you should be able to see it naked eye. I usually don't even try because my eyes aren't that good, but I maybe should, especially when it gets up nice and high.
Yes.
Then you've got a real good chance. It was discovered by Hordernia before 1650, but the identification is uncertain. They're not quite sure whether or not it really is M34. So the next person in line is Messier. He has sighting on the 25th of August, 1764. And this cluster's about 1,630 light years away. Got about 400 stars in it. And, you know, it's just a nice open cluster to go after. And it's not a real dim object, so that's always nice.
Yes. Now let me show folks where to find Perseus. Okay, it's quiz time, everyone. You ready? Here we go. I'm going to make the sky look different. Oh, wait, how about we put the horizon in? That'll make it a little easier. Okay, here we go. Quiz time. Where is the Big Dipper? Anybody? Can you guys find it? Where's the Big Dipper? Good. Where's the Little Dipper? Okay, we're going to connect these two stars. There's Polaris. There's Little Dipper. Good. Where's the Jack in the Box? Where's Cepheus? We're going to continue that line until we see a box and we see stars. Good. Where's Cassiopeia? Okay, so we have the handle star of the Big Dipper or Mizar and Alcor, either one. And then we're going to connect that with the handle star, Polaris, of the Little Dipper. And we're going to connect that until we get to this W over here. We have Cassiopeia. Good. Here, let me connect the dots real quick. How'd you do? Did you guys get those? Okay, good. Now, Perseus is going to be real low northeast, almost dead northeast. So if we're looking north and then we're working east is over here, northeast, Perseus is going to be this guy in here. And he's really just right below Cassiopeia. So once you find Cassiopeia, go straight down to the horizon. And you will see Perseus in there, and you'll be able to see the things that we were just talking about. And, okay,
you know,
did we finish M34?
Well, one thing, Aurora, I noticed on your graphics.
Yes.
Because I've got you. I found out how not to have such a big time lag. You can actually see the double cluster there on your graphics.
Oh, really?
Yeah, there's a little fuzzy patch between Cassiopeia and Perseus, and I can see this little fuzzy patch, and that's the double cluster.
Look at that.
Do you see it there?
Yes. Let me see if I can show people.
I believe it shows up. You know, it's quite easy to see with using averted vision. It really pops out.
It does. It does.
But
okay.
I didn't realize it showed up on your graphics there when you had the wide field view.
That's kind of a bonus, isn't it?
Oh yeah, yeah. It's always nice when you get something like that.
Nice. Okay, how about Andromeda? I know people are wondering what this is over here. So once you find
Andromeda,
Cassiopeia, scoot yourself over to Andromeda. And Kent talked about this in the beginning. There was a great square of Pegasus. You see that
right,
there?
we got the great square, and one corner star is Alpha Andromeda.
That one right there.
And the really nice thing about Andromeda is it's got three bright stars, Alpha, Beta, and Gamma, and they're all stretched out, going from right to left. You start with Alpha, then you go Beta, and then you go Gamma, and they're all like second magnitude stars. But you go the middle one, Beta, which is actually the brightest of the three, and you go up 1, 2 stars, and there's a fuzzy thing up there.
Now, is that a naked eye fuzzy thing?
That's a naked eye fuzzy thing, believe it or not. You got to use averted vision, but that is the farthest object most people can see with the naked eye. It's another galaxy. It's 2.5 million light years away, which is a long, long way, and you can see a couple little satellite galaxies. Messier called it M31. A lot of people know as the Great Andromeda Galaxy. One thing that people may not realize is when you look at your graphics, you see all these stars around there. Well, all those stars are in our galaxy. If you went in a spaceship between Andromeda and the Milky Way and got out with wearing a spacesuit, it'd be totally black. There wouldn't be any stars anywhere. It'd just be total blackness in all directions. And then you'd look down, there'd be a little fuzzy patch in one area, and you could look the opposite, and there'd be another little fuzzy patch. One fuzzy patch is the Milky Way, one fuzzy patch is Andromeda, and there's zip in between. There may be a few odd stars that got thrown out, but for the most, it would look nothing like what we see because we're inside of a galaxy. We have a sky full of stars.
Yeah.
And you wouldn't see that if you were between Andromeda and the Milky Way. So that's kind of a weird thing to think about.
It is. Most people don't realize that. So, yeah. Now, you mentioned a satellite galaxy. Tell me about that. There's two of them I think we were going to highlight.
Yeah. Messier called, the Great Andromeda Galaxy M31. And then we've got two little satellite galaxies. One's very close. That's M32. And then kind of on the opposite side, that one there's M110, which looks more elliptical rather than round. And so those are the two satellite galaxies. Also, I should get on a little bit on the history of the discovery of Andromeda Galaxy. It's probably been known forever, but in the first, when was it? It was 964 AD, a Persian scholar by the name of Al-Sufi made the first written records about Andromeda as being a fuzzy patch. The next guy to actually write down something was Simon Marius in 1612. He saw it used in a very early telescope because 1608 was when the first telescope was made. So this is like 4 years later, and he's looking at the Andromeda Galaxy. So that's some of the history behind it.
Nice. Now, did we talk about 404 yet?
Oh, pardon?
Did we talk about NGC 404?
No, we haven't. Okay. And I just wanted to talk a little bit more about the satellite galaxies real quick.
Oh, yes, please. Go ahead.
Yeah, M31 can be seen in binoculars under good conditions. It was discovered by a French astronomer, Le Gentel, on October 29, 1749. M110 was actually discovered by Messier, but it wasn't put into his list. His list, I think, went to like 104 and stopped. But in 1801, he mentioned this object up there, and so they decided to add it to his list. And at the time they were at 109. This became 110. But also Carolyn Herschel found it independently a little bit later. So Messier gets the discovery credit, but Herschel, Carolyn Herschel gets the independent discovery credit.
Yeah.
Anyhow, that's all I wanted to say about those
perfect.
guys.
Thank you so much. And yes, people are just amazed that you are not reading a script right now. You're actually just answering questions as they come in. Okay, great. So
we want to go to 404.
Let's do the 404. Go ahead.
We talked about beta, using the beta star. You got alpha, beta, and gamma. They're kind of strung out there, roughly in a line. And beta has a galaxy really near to it. It's called Mirach's Ghost. Actually, it's given an NGC number 404, but Beta Andromeda is also called Mirach. And it can be easily seen in an 8-inch scope. It's just like a little fuzzy patch there. It's magnitude 11.7. And let's see if I have any. It's 6.4 arc seconds northwest of Beta. So it's got some separation. It's not too close. Beta itself is magnitude 2.03, and so it's just kind of like a freebie galaxy. Put your telescope on Beta and then wander around.
Yes.
You'll find it. And
yes.
so that's why I threw in 404 on there.
Now, just to recap real quick, so for Andromeda, so when you're at Cassiopeia and you've done Perseus, you're going to come over to Andromeda here. Here, we'll take off the labels and everything. Okay, and so we did Cassiopeia. You guys now know how to find that. Right below it is going to be Perseus, and we looked at this before. Andromeda, we have these 3 stars, 1, 2, 3. And then this is the star that has that ghost he was just talking about, Murex Ghost NGC 404. And then if we go up here, we are going to see the Andromeda Galaxy, which is naked eye. So you'll just see kind of a fuzzy patch. So right in this section is where we're talking about. Okay, go ahead, Kent.
Okay, the next one is Gamma Andromeda.
Yes.
It's magnitude 2.12. It's a beautiful double star. It's got a golden yellow for the brighter star. And the fainter one is, let's see if I actually said what it looked like. I may have lost. Let's see. You got a golden yellow, brighter one, and then the other one is, they've got it blue. Okay, yeah, blue. It's a blue component. So you got a golden yellow and a fainter blue one. It's one of the finest double stars for a small telescope.
Yes.
And so it's easy to find. It's nice and bright with the main component being a 2.12. Then you got the fainter component at 5.08. And they've got a separation about 10 arc seconds. So, that should be easily pulled up at low power on a, small or medium-sized telescope. But it is a nice color difference one.
Yes.
Having the yellow and the blue kind of reminds me of Albariel when we were talking about Cygnus, the swan, and Albariel being one of the better double stars in the sky.
Perfect. Yes, and I've gotten a number of questions about magnitude and how far down we can see. Let us finish the constellations. We have one more to do, Pegasus, and then I'll answer the magnitude questions, the binocular questions. What spacing can I expect to see? What magnitude can I expect to see? So I'll answer those questions as soon as we're done. So Kent, let's go ahead, and are you ready for Pegasus?
Yeah, let's go for Pegasus.
Okay.
The real showcase item, as far as I'm concerned, is Messier 15, which is a really nice and rich globular cluster in Pegasus. And it's got a magnitude 6 star nearby to it, which when you look up in the with binoculars, you'll see this magnitude 6 star, and then just east of it, there's this little fuzzy guy. Or let's see, it's west. Just west of it, but the globular is magnitude 6.2. So if you had really sharp eyes, you might be able to differentiate it, because the star will more look like a pinpoint, where the globular will look like a fatter, fuzzier star. And so that's one way of telling the difference. And there's a few occasions like Messier 5 in Serpents that has a bright star near to it, where basically I find the bright star and then there's a fuzzy thing. I know that's Messier 5. This M15 is 39,000 light years away, and it was discovered in 1746 by a French astronomer, Jean-Dominique Maraldi. So that's about all the information I have. One interesting thing about this globular cluster is it has a planetary nebula inside of it. And there's been some good Hubble photos of that planetary nebula. Under good conditions, with filters, with my 20-inch, I can just pull that one in. So it's not easy, but you can get it in a big scope. And I think that's about all I have to say about that one.
That's really rare, too, to have a planetary nebula inside of a...
It's really unusual. What may have happened is two stars, since the stars are so close, they may have mashed into each other. And so you end up with a single star, what they call blue straggler, that has a lot of fuel. And it can actually evolve to the point it can make a planetary nebula. And so it may have been derived off of, two fairly large stars that ran into each other, made a blue straggler, and the thing was able to have enough mass to make a planetary nebula. Down the line, that thing's billions of years old, probably 10 to 12 billion years old. Most globulars are really, really, really ancient and old, so it's had enough time. In fact, the miracle thing about it is that we happen to see it now, because planetary nebula will only last, I don't know, I've heard numbers from 10,000 to 50,000 years.
Yeah.
And this thing's been out there for billions of years. So we're just lucky enough it's not gone. It just happened to form at the right time where we're around to see it, right now.
Yeah, that is really lucky. All right, Kent, we have probably about 10 million questions that have come in. So hang on just for a second. Brian has been selecting out some that we'll answer. Just really quick to review what we've done tonight. This will take 60 seconds, and you're going to tell me. So if I show you the screen, where's Mars? Ready? Go. Where is it? We're looking east. This is an E. This is an S for south. Here's the Milky Way. Okay, I'm really kind of zoomed out so much that it's starting to fisheye, but that's just my screen. Okay, so do you see Mars? It's low, it's rising. About 10 o'clock tonight on the northern hemisphere, we have a bright orange star on the ecliptic, which means there's two other planets on the ecliptic. Where are they? That's right, they're right by the Milky Way. So if you go south, you're going to see this Milky Way band if you're lucky enough to have dark skies. And you look straight up and you're going to see Saturn and you're going to see Jupiter. Very good. Good. Okay, what else did we talk about? Oh, we talked about Mercury just a little bit, but it's probably already set by the time I've seen this. Okay, so let's see if we can find the Big Dipper. Does anybody see it? Point it out. Okay, good. Can you find Polaris? Really quick, last time. Okay, Polaris is right here. We're going to connect these two stars. Here's the Big Dipper, the bowl. Here's the handle. We're going to find Polaris, which is right there. Okay, can you find the Little Dipper? That's right in here. Okay, now we're going to connect the handle stars of the Big Dipper and the Little Dipper, and where does that take us? Do you remember? Say it out loud. Even if I can't hear you, say it out loud. Cassiopeia is the W or the M or the 3, depending on how it's oriented in the sky around Polaris. Okay, so here's Cassiopeia. Okay, and what did we say was right below Cassiopeia? Do you remember? We had the hero. We had Perseus is down in here. Good. And we talked about a number of things. The owl cluster in Cassiopeia is is in here. And we talked about other Eta Cassiopeia was in here as well. Okay, good. And then here's Perseus. There was a number of really cool things in there that we mentioned. Now look over here. Do you see 1, 2, 3 bright stars? You see this is Cassiopeia. Here's Perseus. And then what were these? Do you remember this? Andromeda, that's right. And so we had alpha, beta, and gamma. Beta, this is where you're going to find the ghost. Go straight up, and here's the Andromeda galaxy with its satellite galaxies as well. Now, where is that great square? Where would you find that? Do you see anything that looks kind of square-ish? Oh, I forgot Cepheus. We'll go back and pick him up. Okay, where is the great square of Pegasus? Okay, there's Mars again. We're going to look east. We're going to go straight up. We're going to see a square that's kind of on a corner. You see that there? Okay, and one of those corners was Andromeda, the 1, 2, 3 bright stars that we saw. Okay, on Pegasus is right off of his nose was the last object that we were just talking about with M15. And if I highlight Pegasus, you can see where his nose is, and that object was right in there. So how'd you do? Cepheus, yes, I completely forgot, sorry. So he was right above Cassiopeia. But we had talked about a number of times how to find him. Okay. All right. Phew. Nice job, Kent. Yay. Okay. Let me answer the binocular questions first, equipment questions. And Kent, while I'm fiddling with binoculars, do you want to talk about magnitude? Just give us like a 40-second
I can give you a quick thing about magnitudes.
Yeah, because you said magnitude 2, you said magnitude 7. What is that?
Yeah, it turns out it goes all the way back to the old Greeks. I think it was Hipparchus, or it could have been Ptolemy, but I think it was Hipparchus. When he made his star catalog, he assigned the brightest stars as magnitude 1, and the faintest stars as magnitude 6. Magnitude 6 is what you can barely see, and then he kind of graded it up, and it turns out that it's pretty close to what we use today for the magnitude scale. It turns out when you go from a 1 to a 6, that's about 100 times brightness increase. So each step of the way gives you roughly about 2.5 times brighter.
So
So
as I go through this scale, though, which way am I getting brighter?
oh yeah, that's the other weird thing. As the number gets smaller, the star gets brighter.
Yes.
So if you end up with extremely bright objects, they have to use negative numbers. You know, this is a modern invention. The Greeks did not know, didn't use negative numbers.
Right.
But yeah, our sun I think is minus 26, so it's way up there. But yeah, it's kind of counterintuitive, but that's
Right.
the way they set it up, and we're big on tradition in astronomy, so we're keeping the ancient Greek tradition alive for magnitudes.
Mm-hmm. Okay, great.
Does
Perfect.
it
Thank
does
you.
that make sense?
Yeah, that's great. Okay, so magnitude, what can I expect to see? Depending on your eyes, of course, it's going to be a little bit different for everyone. So that's why I put magnitude information with all these objects. So you'll be able to say, oh yeah, I can see a magnitude 4. I can see a magnitude 6. So whatever that is for you, so you can kind of gauge what that is. With binoculars, typically, this is a pair of 7, it'll say 7x50, so 7 by 50s is typically how people say it. And so with a pair of binoculars like this, you'll be able to see probably down to magnitude 7 or 8. Again, depending on your eyes. Some people are better. Some people have eyes that, they've lived a good life so far. So the 7x 50 refers to the power and also how much light collecting ability we have. So the 7x will tell us, I'm looking through here and I'm going to see objects 7 times their regular size. And then the 50 is going to be the millimeter size here. So I've got 7x 50s. Notice how they look real similar to my 10x 50s, right? My 10 by 50s, my 7 by 50s. These are $35. These are $150. Honestly, any binoculars you have in the house are probably going to be just fine as long as nobody's dropped them, right, Kent?
Yeah, you drop them. If you look through them and the images don't coincide, they've been dropped. Do not buy them if they look that way.
Yes. Okay, people are asking about these. My new favorite astronomy gadgets. The whole reason to get into astronomy is so you can have gadgets. You get green lasers, you get optics, you get binoculars. These are 25 by 100. So this has 25 times the magnifying power. And then this is 100 millimeters here. So basically, what this is, it's like a 10 or 12 pound small telescope. So I can see things in here that I can see with a 4 or 5 inch telescope. It's smaller, it's lighter. For me, it's more portable. So I'm really enjoying this. And I have double vision, which is great. I can look through both eyes. And this is great, especially if you have kids. Before you buy a telescope, before you even buy binoculars like this, the thing you should be buying is a $20 to $30 to $40 pair of binoculars. This is the best way to start astronomy. Don't buy a telescope because they are useless if you don't know where to point them, right? So before you go buying something like this is an 8-inch Schmidt Cassegrain. This is an LX200. It's made by Meade. Typically, I think they used to sell for maybe $2,000-ish plus bells and whistles. This one has a motor drive. It can track. It can do GPS. It gets the information, and you punch in what you want. It goes bzz, bzz. It's a go-to scope. They're expensive and you need to know how to use them, maintain them, and it's a lot of work. So honestly, what we're doing tonight, just go outside, print out the little star charts that we mentioned in here, just grab a pair of inexpensive binoculars and just go learn the night sky, learn the star patterns. That is the best way to do it. If you're ready to move up, then you're going to go to the last page of the handout, and here are our telescope recommendations. So it's not enough just to say, I want a telescope. We have to know what it is you want to look at. And so knowing that, and also kind of where you are you a teacher? Is this for a kid? Is this for a grown-up? Like, what are your goals and what do you want to look at? So our telescope recommendations are here, and there's a number of them. So please do refer to this so you can take a look. The Schmidt-Cassegrain is great, but it's heavy. So I find myself not using it as much as my Newtonian, which doesn't have a go-to, but I learned the night sky so much better on that thing. And it's the same. It's 8-inch in diameter. And so it's really a personal preference. And that's why I like this one, because it's so light and easy, and I just leave it set up and then I walk outside. So for me, it's worked with the lifestyle and the type of style I have for observing. Other people, they mount a pier and they have a roll-off roof, and that's fantastic. So, okay, so let's go ahead. I hope that answers a lot of the equipment questions. Again, if you're looking for this is called the Sky Gazer's Almanac. Obviously, this is the wrong year, but you'll want 2020, and you'll order the right latitude. And this is, again, from Sky and Telescope. Just look in their online store and you'll find it. The other book recommendation, people are asking what was the book before, Touring the Universe Through Binoculars. This is a great way to get to know the sky. Kent also mentioned H.A. Ray's book on the stars. And it was printed, what, Kent, back in the 50s or 60s?
52, I think, or
52.
something like that.
Yes, so that's also an excellent reference. The planetarium software I was using is called Stellarium, like stellar, Stellar. Stellarium.org. You can download it for free. And the CCAS website, which centralcoastastronomy.org website, has videos on how to actually use it, and so you can get started. So it's not hard. It's really easy. And you can see how powerful it is. We just went through a good section of the sky and talked about a lot of neat things you can see naked eye and also with binoculars. I think there was only one or two telescope objects in there. Okay, other questions? Can we explain? Okay, so we did those questions. We talked about colors. Okay. Binoculars. We got those questions. Wow, we knocked out a lot of these questions. This is fantastic. Brian, let me have your beautiful face on here so it's not just me the whole time. Do you have a couple of questions, Brian, that you would like to voice out to Kent to kind of bring you into this conversation? Brian has been working nonstop. I'm sure there's sweat coming off of him because that wasn't polite. Sorry, because he's been working so hard, frantically answering everybody's question. And also thank you to all the CCAS members and that I've seen on there just answering others' questions. Tom, hi. And Dave, if you're on there, if I missed you, hi. And Glenn. So thank you for helping out as well. We really, really appreciate it. Couldn't do this without you. Okay, so let me see if I can magically make you come up. And apparently I can't make you come up. Where did you go? Okay, hang on a second. I have lots of layers on my computer screen right now. So let me find him. He's underneath a lot of layers. Okay, there you are. All right. Hi, Brian. If you're wondering who is the man behind the furious typing, here he is.
Yes, there's me, the furious typing.
So first of all, thank you, Brian. Yay!
Oh, you're welcome. Sure thing. It's a pleasure. So many amazing questions.
Awesome.
Yeah, so I think that you've actually addressed most of the questions. I did find one that was interesting equipment-wise. Did you have a chance to bring up image stabilization?
I did actually.
Okay.
I did bring up image. Let me get the picture on it. Or if you have one, you can share it.
No, I don't have a picture. I was just going to bring up a concept that I think that there's some advertisement we have to watch out where people are trying to market image stabilization as if it's some kind of active optics to clean up poor viewing. And we would say that that is not the case. It's mostly for helping from handshake or however you're holding the binoculars, right?
Yeah. This is my image stabilization right here.
Yeah.
And it happens to everyone. As soon as you breathe on the binoculars, so these binoculars are heavy, and so they need their own tripod. Oh, I don't even know if people can see me. They're looking at you.
Yes, you are. You're at the top of the thumbnail.
I'm at the top. I'm at the top. Let me make myself huge. Okay, here we go. So so these binoculars are heavy, so they have to have a tripod. You don't need to buy the fancy tripod that they've matched. You can use an old one from like video cameras. For those heavy video cameras, you can use that as well. It has to have a pan head and so forth. But it takes a good 5-10 seconds after you move it into position for everything to even out. And like Kent was saying in the beginning, when you're viewing Mars, you have to wait and be patient for the air to steady down, and that's using a telescope. So astronomy isn't a, oh, wow, whiz, bang, look at that, look at that. It's a much more subtle art to viewing and learning how to look. There are some things that you can only see when you look straight on, and some things you can only see when you look off to the side, and then it'll pop into view. So there's a lot of fine details that need to happen, and it's an art form that you start to develop. It's a skill.
Yes,
Hey,
definitely.
Aurora?
But
Yes, Ken.
I've got. Have you ever tried vibration suppression pads on a tripod?
Have I tried I missed half of what you said. Say it one more time.
Oh, they have these orange hockey pucks called vibration suppression pads, and you put one under each leg of a tripod, and they actually work. They actually suppress vibration. They came out with them, years and years ago, but I was just curious if you had them or not.
I'm muted. Sorry. No, I
Yeah,
haven't
to me
tried those.
they look like a hockey puck.
Yeah.
And they have like an orange, the
I've got a
orange
picture of
plastic
it.
on the outside, and then a really kind of gooey plastic on the inside, and then a hard little plastic piece. There they are, vibration suppression pads. They actually work.
Wow.
I mean, there were all sorts of suppression pads that you paid a lot of money for, and they didn't work. But yeah, vibration suppression pads actually work.
Perfect.
You can see the little orange. The orange
Yeah.
is like a real soft material, absorbs the vibration.
Okay, good to know.
With my old C8, when I looked at Saturn, I'd have to adjust the focus, then move my hand away and see if I had it focused right or not, because you always introduce vibration when you adjust the focus.
Yeah.
And with the vibration suppression pads, I was able to focus right on, and none of this, having to wait for the thing to settle down. So they actually work.
Nice.
In fact, they work so well that I believe Celestron bought the patent from the guy that was originally selling them. Either it was Celestron or Orion. One of the guys came in and swooped in and bought up the patent and doubled the price.
Yeah, they look like they're $50 for them.
They used to be $30.
Ah, well.
and these guys bought up the patent because it was the first vibration suppression pads that actually worked.
That actually work. Okay, well, that's good. Thank you so much. I'm going to look into that later because that is a problem. Definitely. That is constantly up. Brian, do you have more questions that you would like to share?
I think that we have answered really everything that has come up.
Okay, great. Well, we're going to go ahead and close it out. I know we've had a great one. We've had a great session. Wait, before you close the window, a couple of dates that are coming up. Put it on your calendar. So we have Stargazing. The next session, we'll be doing this. Hang on. I got like 3 thoughts all at the same time. Sorry. Smoosh. If you enjoyed tonight's presentation, 2 quick things. Go ahead and subscribe to our YouTube channel so you'll get notifications when we do our next Stargazing, which is October 17th. And also let Kent know in the comments how much you enjoyed it and what specifically you really enjoyed the most for tonight. We actually copy and paste all those and send him a huge old email. So if you want to let him know anything about tonight, how much you enjoyed it, thank you so much, anything like that, just let him know. That way he will get that in an email from us. And so he does this completely free of charge. He just loves to share his passion with the night sky with the public. And so this is one of his ways he can do that. So thank you for being with us. So the next Stargazing is tentatively scheduled because we technically, Brian, we haven't asked Kent if he's available.
Oh yeah,
October
that's
17th.
true. That would be a good thing to do.
So we'll do that offline, but pencil it in, and Kent will figure out if you're available. And the next member hangout is actually in a couple of days. It's September 24th. So if you are a member of the Central Coast Astronomical Society, then, oh, perfect, thank you. And so if you're a member of the Central Coast Astronomical Society, or if you'd like to be a member, you can be a member tonight. It's $20 for the entire year. You can go to our website, centralcoastastronomy.org. We are having a members only hangout where all the members get together, and it's a giant Zoom call, and they actually just get to talk, ask questions. Hey, look what I photographed last night. I can't get this thing to work, help. And so it's a really cool opportunity for people to just connect that just love the night sky. And you could be from anywhere in the world. And so we welcome
Aurora?
that. Yes.
I got a question for you.
Yes.
I don't know if it's been mentioned or not. Have we ever talked about subscribing to either Sky and Telescope or Astronomy magazines? Because those are the two tops. And, you know, they're excellent sources of information and also to get you interested.
Yes.
And so I was curious if we'd ever brought that up on our talks.
I don't think I ever have. So, okay, here, Sky and Telescope magazine. As a member of CCAS, you get a discount on these magazines. And so that's not something I think I've ever mentioned. It's usually like, oh, by the way, we'll save you money. So Sky and Telescope is one of them, as so is Astronomy magazine.
Yeah, astronomy. I subscribe to both of them, to tell you the truth.
Yes, I do too. I have both of them. And so they have star charts that, oh, look, they're trying to sell me something. Okay, so they have star charts inside. You can subscribe to these on your own. You just hit the subscribe button. These are great, and they come out monthly, and they will keep you hopping as to what you should be looking at. And they come out a few months in advance, so you have time to look up what you want to know about in there. So yes, and they come in online versions as well. The thing I was showing you tonight was my online version that I have. This is the actual magazine. You can see it here that we're flipping through pages. And so it's a great resource. So if you are remotely interested in astronomy, you should be subscribing to them as well. And so if you're a member of our club, we also offer discounts for those. And so the information's on our website. You can check that out. So thank you for that recommendation. Oh, and the pens is the other question. Ha ha ha. I actually didn't open mine yet. So thank you, Glenn. I just got it in the mail. And so Glenn is one of our members for Central Coast Astronomy, and he is hand making astronomy pens. Ooh, this is gorgeous, Glenn. Nice job. And so he is hand making these pens. And so I just bought mine. That's amazing. Nice job. If you are also interested in, he does have some availability left. And so you would arrange with him to do that. And the easiest way is to go to centralcoastastronomy.org/PEN, or if you just go to .org, centralcoastastronomy.org, go down to where you see some pens. And you can find out more about that, about how he's doing that. And so all the proceeds go back into the club itself. He's actually just doing that as a thank you for the club. So this is something that you can look up as well. So thank you. You put the pen link in the chat. Oh, thank you. That was awesome.
You're welcome.
Okay, and so you can find out more about how he's doing that and pick out the colors. And it's a fantastic gift for somebody who loves astronomy. And my husband doesn't know this, but he is going to get this. This is for him. His birthday is coming up very soon. So shh, don't tell. Okay, other questions. Other book recommendations. If you look on our website, we have a bunch of recommendations for equipment and all that sort of thing. So just go to centralcoastastronomy.org. Other questions. I have another question. You didn't answer it. Okay. If you didn't get a specific answer to your question, please just email us questions@centralcoastastronomy.org, and we are happy to answer your questions individually. Okay. So go ahead and just type that in. All right, Kent, thank you so much for being with us tonight. You've been my coach and mentor and guide for 15 years?
It's been a while.
It's been a while. So gosh, I can't thank you enough. I used to park my little telescope right next to him and just listen to what he was saying and just absorb and soak it in. And when I was stuck, I'd be like, Kent. He's just always so happy to help. So thank you from the bottom of my heart. Thank you for sharing your love.
Well, thank you very much. It's been fun.
So thank
I'll
you,
let
Kent.
you
We
go
will see you
now.
next time. Take care.
Okay, take care. Bye.
Bye-bye. All right, Brian, we got to thank you for you too. Where are you? Right. So thank you, Brian, so much. Yay!
Oh, you're welcome. Thank you.
For helping with all the questions that I know you got pummeled with. Thank you again. So go ahead and drop Kent or Brian or both. Thank you in the chat box as well. And so thank you all for being here tonight. I will see you next time. The next Stargazing again is October 17th. We'll make sure Kent's available. And the next hangout for Central Coast Astronomy is on the next Thursday, the 24th of September. Your Zoom camera just turned off. Oh, yes, that can happen. Okay, so I'm still live though, so I think I'm okay. And we're about to go off the air. Yes, okay. So if you do have questions, let us know. Questions at centralcoastastronomy.org. Go ahead and enjoy your night. Get out there, get your binoculars, or just take your own naked eyeballs outside and check it out and look up and see if you can find the Big Dipper, the Little Dipper, Mars, Jupiter, Saturn, the Great Square of Pegasus, all those things we talked about. This is yours. This information is good for at least a couple more months. And so start now and just start small. Just start with something, try one new thing each night and step yourself through it. All right, thank you again, everyone. Have a wonderful night, and I will see you at the next Stargazing event. Take care. Bye-bye.
Bye, everyone.